last class we discussed about square close packing in 2 dimension, and today we will discuss about hexagonal close packing in 2 dimension. So, I have made the picture here. 2 dimension means you will having both x axis as well as y axis. So, this represents the x axis and this represents the y axis. So, the first layer I have arranged, I am just going to give it as A. Now, see the second layer. Second layer I have just arranged in the voids of the first layer, that is in the gaps you see of the first layer, there I have arranged the second layer. Now, the second layer is not identical to first layer. Is it identical to the first layer? No. So, this I am going to name it as B. Now, you see the third layer. Third layer is vertically aligned with the first layer. So, the third layer is identical to which layer? The first layer. So, again I can call it as A. So, the third layer is named again as A because it is identical to which layer? The first layer. Now, you see the fourth layer. It is again arranged in the voids of the third layer. So, the fourth layer becomes identical to which layer? Second layer, or the fourth layer is aligned in the same place of the second layer. The fourth layer is aligned with the second layer. So, the fourth layer is identical to the second layer. So, I can call it as B. So, next you say what will be the fifth layer? Fifth layer will be identical to what? The third layer. The sixth layer will be identical to what? The fourth layer. So, that is being repeated. So, what are you getting? AB, AB, AB type of packing. So, here you see I am just going to take a sphere here. I am taking this sphere. So, this is in contact with how many spheres? 2 here, 1 here, 1 over here and 2 here. So, you are getting the shape of what? A hexagon. So, that is why it is known as what? Hexagonal close packing in 2 dimensions. So, a sphere is in contact with how many spheres you see? 1, 2, 3, 4, 5, 6. So, in hexagonal close packing in 2 dimension, each sphere is in contact with 6 other spheres. So, the coordination number will be what? 6. So, the coordination number of hexagonal close packing in 2 dimension is how much? 6. Is it clear? Now, you take another one here. Take this sphere at least. So, it is in contact with 2 here, 2 on the side and 2 here. So, here also say the coordination number is what? 6. So, understood what is hexagonal close packing in 2 dimension. First layer you are arranging it and you are calling it as what? A. The second layer is arranged in the voids of the first layer. So, what do you observe? The second layer is not identical to the first layer. So, we have named it as what? B. Then the third layer is aligned vertically with what? The first layer. So, the third layer becomes identical to what? The first layer. So, you are naming it again as what? A. Then the fourth layer is arranged in the voids of the third layer, or it is aligned with the second layer. So, the fourth layer becomes identical to what? The second layer. So, this is being repeated. So, this is known as AB, AB type of packing. AB, AB type of packing in 2 dimension, or it is what? Hexagonal close packing in 2 dimension, and each sphere is in contact with how many spheres? 6 spheres. So, the coordination number is what? 6. So, is it clear? In case of hexagonal close packing in 2 dimension, each sphere is in contact with 6 other spheres. So, the coordination number is 6, and this type of packing gives you AB, AB type of arrangement. Now, in square close packing, the same thing was repeated. So, we called it as what? In case of square close packing, we called it as AA, AA type of packing. And what was the coordination number? The coordination number was 4. So, is it clear? Next we will discuss is about hexagonal close packing in 3 dimension. for hexagonal close packing in 3 dimension means you have to take into account the 3 axes x, y and z, and it is difficult to make it on the board. So, first we will take the hexagonal close packing in 2 dimension. Okay. Now, in case of hexagonal close packing in 2 dimension, you see, last class I just discussed about the voids. Here you see 3 spheres are touching. So, what void are you getting? It is a triangular void. So, this is a triangular void, I am going to give it as B. In this case, in this triangular void, see the apex is or the tip is towards upwards, and this is also a triangular void, the tip is towards downwards. So, the tip upwards I am going to name it as B, and the tip downwards I am going to name it as C. So, this is again B, this is C, B, this is C, this is B, C, B, B, like that you will be getting. So, these are the voids. So, in the total packing you get what type of voids? Triangular voids. That is, in order to explain hexagonal close packing in 3 dimension, we are going to consider hexagonal close packing in 2 dimension. So, in hexagonal close packing in 2 dimension, you have got only what type of voids? Triangular voids. And there are 2 types of triangular voids, one with the tip facing upwards and the other with the tip facing downwards. So, the triangular void with tip facing upwards, have named it as B, and the triangular void with tip facing downwards, I have named it as what? C. So, this total, this I am going to give it as layer A. So, this is known as layer A. Now, we have to arrange the second layer. Now, the second layer, you can arrange it in the triangular voids marked B or in the triangular voids marked C, either in B or in C. It is not that half you are going to arrange in B and half in C. It is not like that. You have to arrange it either in the triangular voids marked B or in the triangular voids marked C. So, I am going to arrange it in the triangular voids marked C. Is it clear? That is, in case of explaining hexagonal close packing in 3 dimension, we are going to consider hexagonal close packing in 2 dimension. And so, that diagram is already there in the board. So, that I am going to mark it as what? A, layer A. And here you have got what type of void? Triangular void, and there are 2 types of triangular voids, one with tip upwards and another with tip downwards. So, one with tip upwards I am going to mark it as what? B, and that with tip downwards I have marked it as what? C, tip or apex. Okay. So, there are 2 types of triangular voids B and C. Now, to arrange the second layer, you can arrange it either in the triangular void B or in the triangular void C. You can't arrange both in triangular voids B and C. Any one only you have to consider, either B or C. So, we are going to arrange the second layer in the triangular voids marked C. After arranging the second layer in the triangular voids marked C, you get it like this. So, is it identical to A? It is not identical to A. So, we will mark it as what? B. It is marked as B. So, the second layer is arranged in the triangular voids marked C. So, after arranging the second layer in the triangular voids marked C, you get a new layer. It is not identical to A. So, we have called it as what? B. So, now we have got 2 layers, A and B. Now, see the figure properly. After arranging the second layer, that is B, now you are getting 2 different types of voids. So, you are getting how many voids? 2 different types of voids. See carefully the figure, you can see 2 different types of voids. In one case you see 3 spheres are in the bottom, 1 at the top. So, it gives you how many spheres are touching? 4 spheres are touching. So, it gives you what type of void? Tetrahedral void. It gives you a tetrahedral void. Then you see another case, 3 spheres at the bottom and 3 spheres at the top. So, 6 spheres are touching, see carefully in the figure. 3 spheres at the top and 3 at the bottom. So how many spheres are touching? 6 spheres. So what are you getting? Octahedral void. So is it clear? That is, after arranging the second layer in the voids marked C, you are getting a new arrangement, and that we have named it as what? B, because B is not identical to A. So after arranging the second layer, now you are getting two different types of voids. See the figure carefully. In the figure you can see 3 spheres in the bottom and 1 at the top. So total how many spheres are touching? 4. So it's what type of void? Tetrahedral void. And then 3 spheres at the bottom and 3 at the top. So 6 spheres are touching. So what are you getting? Octahedral void. Is it clear? See the figure properly. So after arranging the second layer, that is the B, which is not identical to A, we are getting two different types of voids, tetrahedral void and octahedral void. So the figure is clear to you. See carefully the figure. 3 spheres bottom and 1 sphere at the top gives you what? Tetrahedral void, and 6 touching spheres, that is 3 at the bottom and 3 at the top, gives you what? Octahedral void. Now there are two options for arranging the third layer. So there are two options for arranging the third layer. That is, you can arrange either in the tetrahedral void or in the octahedral void. Is it clear? That is, for arranging the third layer, we have got two options. Either it can be arranged in the tetrahedral void or in the octahedral void. So let us see what type of arrangement are we going to get when it is arranged in the tetrahedral void and in the octahedral void. So when the third layer is arranged in the tetrahedral voids of the second layer, the third layer becomes identical to the first layer. So we will name it as what? A. The fourth layer will become identical to what? The second layer. So we will call it as what? AB. So this AB type is being what? Repeated. So this is known as AB type of packing. And what is the name given in AB type of packing in 2 dimension? We call it as what? Hexagonal close packing in 2 dimensions. So here we call it as what? 3 dimension. Is it clear? So when the third layer is arranged in the tetrahedral voids of the second layer, the third layer becomes identical to the first layer. So the same thing is being repeated. So we get AB type of packing. So it's known as hexagonal close packing in 3 dimension. So in case of hexagonal close packing in 3 dimension, the type of voids occupied is what? Tetrahedral void. So when tetrahedral void is occupied of the second layer, you get hexagonal close packing in 3 dimension. And in this case, you know, each sphere is in contact with 6 spheres in its layer. See the figure? In the figure you can see each sphere is in contact with 6 spheres in its own layer and 3 spheres above and 3 spheres below. So what will be the coordination number? The coordination number will be 12. See the figure carefully. In its own layer, it is in contact with 6 spheres. Top 3, similarly at the bottom also what will come? 3 will come. So the coordination number is what? 12. So in case of hexagonal close packing in 3 dimension, each sphere is in contact with 6 spheres in its own layer, 3 at the top and 3 at the bottom. In the figure only the top portions I have shown. Similarly, it will come in the bottom also. So 3 at the top and 3 at the bottom. So the coordination number is what? 12. But in case of 2 dimension, what was the coordination number for hexagonal close packing? It was 6. That is, we are taking into account only the spheres in its own layer. That is, each sphere is in contact with 6 spheres in its own layer. But in case of 3 dimension, we have to take the 3 axes. So in its own layer, it is in contact with 6 spheres, 3 at the top and 3 at the bottom. So is it clear? Hexagonal close packing in 3 dimension, that is, after the arrangement of the second layer in the triangular void of the first layer, we get a new type of layer. So we call it as what? B. So AB. Now after arranging the second layer, we are getting 2 different types of voids. One is tetrahedral void and the other one is what? Octahedral void. So to arrange the third layer, we have got two options. Either we can arrange it in the tetrahedral void or in the octahedral void. When you arrange it in the tetrahedral void, what do we observe? The third layer becomes identical to the first layer. So automatically the fourth will be identical to what? Second. So what is being repeated? AB, AB is being repeated. So you are getting what? AB, AB type of packing. So we call it with the same name. It is known as hexagonal close packing in 3 dimension. We can't call it as 2 dimension. It's similar to 2 dimension. It's hexagonal close packing in 3 dimension. So in this case, each sphere is in contact with 6 spheres in its own layer and 3 above and 3 below. Is it clear? So the coordination number is 12. Next option is what? What is left? Octahedral void. You can also arrange the third layer in the octahedral void. So when the third layer is arranged in the octahedral void of the second layer, you see the figure. Are you getting what is written there? C. C means it's not identical to A or B. That means you are getting a new type of arrangement. So what will you call it as C? So you are getting first layer was A, the second one was B, and the third, when it is arranged in the octahedral void of the second layer, the third is not identical to either the first or the second. So we will name it as what? C. So in the figure you can see C, that means A, B, C. That is A is different, B is different, C is different. That means the first layer is different, second layer is different, and the third layer is also different. That is, when the third layer is arranged in the octahedral void of the second layer, the third layer is not identical to the first layer or the second layer. So we call it as what? C. So you are getting what? A, B, C. Now the fourth layer becomes identical to the first, the fifth becomes identical to the second, and the sixth becomes identical to the third. So what is repeated again? A, B, C. So what are you getting? What type of packing? A, B, C, A, B, C type of packing. Is it clear? That is, when the third layer is arranged in the octahedral void of the second layer, the third layer is not identical to the first or the second. So we name it as what? C. The fourth layer becomes identical to the first, the fifth becomes identical to the second, and the sixth becomes identical to the third. So we call it as what? ABC, ABC type of packing. And this ABC, ABC type of packing is known as cubic close packing in 3 dimension. It is known as cubic close packing in 3 dimension. Now see the figure also. Here also the coordination number remains the same, that is 12. That is, each sphere is in contact with 6 spheres in its layer, 3 above and 3 below. So what will be the coordination number? 12. So for cubic close packing and hexagonal close packing in 3 dimension, the coordination number is what? The same. That is, each sphere is in contact with 6 spheres in its own layer, 3 above and 3 below. Is it clear? So this is known as hexagonal close packing in 3 dimension. Once more I will explain. So to explain the hexagonal close packing in 3 dimension, we are considering what? Hexagonal close packing in 2 dimension, and that we have named as what? A. Then in hexagonal close packing in 2 dimension, you have got 2 voids, same type of 2 voids, that is triangular voids, one with tip upwards and one with tip downwards. So we have named it as what? B and C. So there are 2 options to arrange the second layer. Either you can arrange in the triangular void B or in the triangular void C. So we are arranged it in the triangular void C. So what do you observe? B is not, the second layer is not identical to the first layer. So we call it as what? B. After arranging the second layer, we are getting 2 different types of voids. One is tetrahedral void and the other one is octahedral void. So to arrange the third layer, we have got 2 options. We can arrange it either in the tetrahedral void or in the octahedral void. So when you arrange the third layer in the tetrahedral void, what do you observe? The third layer becomes identical to the first layer. So we call it as what? A, and the fourth layer becomes identical to the second layer. So we call it as what? B. So what type of packing are you getting? AB type of packing, and it is known as hexagonal close packing in 3 dimension. And here each sphere is in contact with how many spheres in its own layer? 6 spheres, 3 above and 3 below. So the coordination number is what? 12. Now when you arrange the third layer in the octahedral void of the second layer, the third layer is not identical to what? The first layer or the second layer. So we call it as what? C. The fourth becomes identical to the first, fifth becomes identical to the sixth, second, and the sixth becomes identical to the third. So what is repeated? ABC type of packing, and it is known as cubic close packing in 3 dimension. Here also each sphere is in contact with 6 spheres in its own layer, 3 above and 3 below. So the coordination number remains what? Same, that is 12. So for hexagonal close packing in 3 dimension and hexagonal close packing in 2 dimension, the coordination number is different. For 3 dimension the coordination number is 12, and for 2 dimension it is what? 6. But for cubic close packing and hexagonal close packing in 3 dimension, the coordination number remains what? Same, 12. What is the difference then? In case of hexagonal close packing in 3 dimension, the void occupied is tetrahedral, and for cubic close packing in 3 dimension, the void occupied is what? Octahedral. And so the names are what? Hexagonal close packing in 3 dimension, just remember what will be the void? Tetrahedral. And cubic close packing in 3 dimension, what will be the void? Octahedral. Void is being occupied. Now see square close packing in 3 dimension. Square close packing in 2 dimension we had studied. Here also it is the same, only the same layers are being arranged. So you get what type of packing? A type of packing only. But the difference is what? In case of square close packing in 2 dimension, the coordination number was what? 4. In square close packing in 3 dimension, the coordination number is 6. That is 4 spheres in its own layer, 1 above and 1 below. Only that is the difference. So square close packing in 3 dimension, the coordination number is 6. Last class I just explained to you tetrahedral voids and octahedral voids. Voids formed by touching spheres is known as what? A void. Now how is a tetrahedral void formed? I said 4 touching spheres. Now in a close packing, how is a tetrahedral void formed? You see here carefully, making it. So this way I have made. So what is the meaning of this? 2 spheres in front and 1 behind. So 3 spheres are touching. Then 1 sphere I am going to make it here. That means this sphere is above this. So when this 4 spheres are in contact, you get a tetrahedral void. See here. Here what are you getting? You see. What type of void are you getting? This is a triangular void, and this is in contact with this when you touch it. See. Somewhat it's what? A shape of a tetrahedron. So the void formed is what? Tetrahedral void. So a tetrahedral void is formed by how many spheres? 4 touching spheres. 3 in its own layer and 1 above. Is it clear? See, 2 spheres in front and 1 behind. This gives you a triangular void, and this is the 4th sphere. So when this 4 spheres are coming in contact, you get what type of void? A tetrahedral void. Then you see octahedral void, I said 6 touching spheres. So 6 touching spheres means 3 spheres above and 3 spheres below. See here. Here you see 2 in front and 1 behind. Here 1 sphere in front and 2 behind. So how many spheres are touching? 6 touching spheres. So when I join it, you get it this way. Here when I join it, I am getting it this way. Wait. So this is a triangular void. So one tip is upwards and the other one's tip is downwards. So this gives rise to what? A octahedral void. See here, 2 triangular voids. So how many spheres are touching? 6 spheres, 3 top and 3 bottom. So that's how an octahedral void is formed. 6 touching spheres, octahedral void. In the last class I just made the spheres and I just showed you, but it's like that, 3 spheres in one layer and 3 in another layer. That gives you what? Octahedral void. Then tetrahedral, 3 in one layer and 1 in another layer. So that gives you what? A tetrahedral void. So 4 touching spheres and here 6. In next class, we will discuss the relationship between voids and number of atoms. What is the relationship between tetrahedral voids and number of atoms, and what is the relationship between octahedral voids and number of atoms. Already we have studied, in case of FCC, the number of atoms is what? 4. So, we will be studying the voids are present, that is tetrahedral voids and octahedral voids are present in face centered cubic unit cell. So, the relationship between number of atoms and tetrahedral voids and octahedral voids, that we will discuss in next class. Is it clear? Hope you have understood it. Just go through your textbook thoroughly.